Hi, my name is Mark Briscoe and I'm a product marketing manager with Tektronix. In this demonstration, I'm going to show how the 6 Series MSO can be used to demonstrate jitter measurements using a math channel as a pseudo-differential signal. Now for this particular demonstration, I'm using a Training Board 3 demonstration board. And I've got an SMA cable hooked up to the positive output of a signal to channel 1 and another SMA cable hooked up to the negative output of the signal to channel 2. I've also flipped on the power for the Training Board 3 and I've verified that the 7-digit displays both read 0, 0, which is going to output a 2.5 gigabit per second 8B10B signal that's very similar to a PCI Express Gen 1 signal. Now on the instrument itself, I'm going to take advantage of recalling a session file just to speed up the setup of the instrument. And I'm going to do that by going to File, Recall, and just double tapping the session file that I'm interested in. Now you'll notice that this session file, not only does it provide the full setup of the instrument, but it also includes acquisition data. And the acquisition data is actually placed back into acquisition memory. So you can actually demonstrate most of the functionality on the instrument without having access to live signals. Now if you do want to acquire live signals, and I'll do that here today, you can just simply press the Run Stop button on the front panel. Okay, and you'll see that we start acquiring acquisitions now off of the demo board itself. Now there's several things to notice in the display, starting with the data rates measurement right here over on the side. It's reading 2.500 gigabits per second, which is what we would expect coming from this signal. Just below that is a set of measurements that are called jitter summary. And a jitter summary is a collection of the most common jitter measurements like time interval error, total jitter, random jitter, and so forth. When you add a jitter summary measurement to the system, those measurements are automatically configured for the user. There's very little setup for them to do. It's very quick to get there. For this particular product, the jitter, total jitter is running about 21, 22 picoseconds. Now the extremely low noise front end of the 6 Series MSO coupled with the very high accuracy time base allows us to have class-leading jitter measurements. And when you add a jitter summary to the system, some plots get added as well, starting with the eye diagram up above here, and then continuing with the time interval error, TIE spectrum, and a histogram of the TIE measurement values, and lastly the bathtub plot over here. Now, the last thing I want to point out is this measurement table at the bottom of the screen. This is a results table for the measurement values in the jitter summary. Each measurement has its own row here, and there's two portions to this table. The left side is the measurement values and the statistics from the most recent acquisition, whereas the right side is the measurement values and the statistics from all acquisitions since the memory was last cleared. Timing and jitter measurements are key tasks for embedded memory system and high-speed serial designers. Now whether you're using demo session files or live signals, you can demonstrate much of the capabilities of the 6 Series MSO's jitter analysis